Okay.
We are discussing cells iteration 2 and what it takes to get us to be able to demo cells iteration 2, where user can create a group. The same user that is like stored on cell 1 can create a group on the cell 2. I asked Tonk, like, after looking at the epic, what he learned about the epic, what is not clear, and what else we can focus on today's meeting.
Yeah, so I think yesterday's session with just walking through the epic is good. So the iteration 2 is simpler than I thought. It's basically that, which is good. But I think there's a lot of details that we need to work through. I think all the major issues is there. What I miss is, which I didn't have time to look for, was any MRs that you might have been working on, Camille. Yeah, to categorize or find all the cross joints. But I know we got the cross joints analyzers, but how do you have some MR to categorize, like what's port, what's cluster wide?
Okay, so maybe let's go step back again from like still kind of similar process as I was going with you yesterday.
Sorry to interrupt. Should we take notes for this? I think. What about in the sync document?
Sure, fine. Can you take a notes? I'm also gonna record that and post recording later, just for that. So I'm gonna be talking about like the epic. Okay, so sharing of my screen. Can you see my screen? This is like the end goal of the iteration 2. We want to record a demo, and the demo has like a very specific prescription. The idea behind the demo is like user account is shared basically across cells. So when you log as a root user on the cell 1 to this host, which is like can be like your GDK 1, you can go and create a new top level group on that cell. And all the existing functions continue working as desired. But you're gonna have another GDK configured on a different port. And because you share a hostname, the session cookie is gonna be shared across these two different cells. So when you go to the cell 2, you should be still logged in as the same user. So your user account is shared across all cells as part of the cluster-wide tables. So when you go to the cell 2, the idea is like we don't have to fix all views. We have to basically be able to go to this page, create a new group, click this button, create group, type in the group name, new group on cell 2, create a group button, and after a few seconds, just be presented with this view of like a dashboard of that group. And the idea of that is like you can execute that on the cell 1, which is like all the existing function, and you can execute that on the cell 2, which is like something new. But me as an IU fan or like a root in the GDK is the same account basically on both of them. And as a result, like if for whatever reason we also get explore function working, the cell 1 we only gonna see this group created on the cell 1, on the cell 2 we're gonna only see a group created on the cell 2. This is demo. We don't need anything else. Just the simplest, the most basic and most common workflow that people even start with at GitLab.
It's similar to what you have done before once, right? Once you did some like POC demo. It's similar to this one, right?
Yes, it's similar, but I had separate accounts there. It was not the same account. So basically, I had users table replicated on both databases, So all the foreign keys were kept intact, cross joins were happening, but just by the coincidence of me storing the same encryption password with the same hashing, it just worked. with the same source and things like that. It just worked that I could use a cookie across. But if I would, for whatever reason, change a password on cell 1 in my POC, it would not work. I would not be logged into cell 2 then, because the password encrypted would be of different form. So there was no data synchronization of the users. Like the primary purpose here is like users are shared, and you as a user can create a group on the cell 2. Which is like the most essential workflow. So you are correct, it worked, but it worked by the keeping data in sync manually, basically ahead of the time. I had this command basically that I ran on the cell 1 and the cell 2 to set exactly the same encrypted password, basically. So that's the end goal. Is it clear? Like, do you need some extra clarification on the demo? Any questions? What would it be else needed there? No, it's clear.
No, it's super clear.
And now, in order to be able to log in as a user across cells, we effectively need to make users and some set of the tables cluster-wide. This is, as part of this record all queries that I did some time ago, I recorded all the SQLs that were executed as part of this workflow when I create a new group. And I saw all of these tables being touched by either going to a page, clicking button, create a group, or side key job being executed. These were all tables that were touched by that workflow. So now, this is, I think, the most essential part, because we not only have to make users to be part of the cluster-wide, but also some of these tables, because they, for example, store some data that we access that application may require. There may have some foreign keys. So some of these tables, they need to be marked as the GitLab main cluster-wide, and then each of these models needs to be based to use main cluster-wide application record to access cluster-wide database. So when you go to the cell2, when you access, let's say, user details, it's gonna go to the cluster-wide database to fetch this information. So this table is gonna be shared across clusters. Across cluster. The thing is, like, we don't need to fix all of them. We need to fix only some of them, I think, to make this to be like a happy path. Because as part of the demo, we focus on the happy path. We don't focus on the edge cases. So as long as we can get this work with the minimal set of the changes, this is our goal. We don't have to fix all of this. And in some cases, it's gonna be hard to break across joins because, for example, roots and redirect roots is like join extensively across code base with the namespace. It's preloaded very often. So in some cases, it's gonna be hard for us to make these cluster-wide changes, but also we don't need to fix all of them. We need to fix only some of them. Probably we need to fix user details, like probably user preferences, maybe user statuses. Plans, it's fairly isolated. Licenses is isolated, but maybe we also have to fix that. But I don't think we need to fix roots and redirect roots to achieve the user can create a group on cluster on cell2. This is the GitLab main cluster-wide side of the story. There is another issue that talks about the same thing from the namespace perspective, because there is like a number of namespace adjacent tables that were touched. I was kind of looking at the list. This was like probably a list of the tables that should be marked as a GitLab main cell that were touched. namespace settings for sure, merge request, issues, graph features. Probably we need to probably set some of these tables to GitLab main. So, but also the minimal amount of possible to fulfill the goal, because they're gonna create a lot of cross joins violations. And the idea is like to focus only on the happy path. So this is like step before a demo, but if we go further, it's actually this issue that is probably like right now the most important. There is like, I merged a change that puts users and namespaces into separate schemas, but it's still allowed to cross-join to GitLab main cluster-wide. As soon as we remove that line, there are gonna be a number of the cross-joins violations that we need to somehow fix. Either make pipeline green by making this explicit allow cross-joins, or add them to the cross-join allow list. And this is really like the first issue that is like of the big size that's gonna require identifying these most important cross joins. But basically the process for getting to the demo is basically the same. We go with the cross joins between users and namespaces. We identify these cross joins. We maybe not even fix them now, because we don't need to fix them now. We need to identify them. We're gonna figure out which one to fix later. Then we go to basically some of these user table and say, okay, from looks, it seems like that user statuses and user preferences needs to be cluster-wide. From that side of the things, it seems to be that probably projects needs to be cell local. So you change the specification, you get a new list of the cross joins that are violating between this set of the tables. You kind of allow that, identify and allow them, and kind of it's rise and repeat. Basically, you're gonna add one more table, it's gonna create a new violations, you need to fix them to get a pipeline green, until you kind of, let's say, exhaust, until you kind of get to the point that when you click the button, create a group, you're gonna observe all of your violations being registered, basically. Because then out of that list of reported queries that I saw, those was like the cross joins that I observed. And from that list of the cross joins that it seems that we have to solve, it seems that this is the only one that we have to solve that is like a cross join that would block this workflow. So the majority of the work is really about classifying a table, whether it should be cell or cluster, and fixing these individual cross joins that are crossing the boundary. And it appears that there is only like one or maybe two or three, because I also kind of changed some cross joins to block today and explicit select. But there is just like a very small number of cross joins that is from the allow list that we would create that we actually have to solve for that workflow. And this is basically rise and repeat process. You identify cross joins that are existing for users and namespaces, you add more tables, you classify more tables, you get more cross joins violations, you identify them until you get in your workflow all of the some cross joins that you have to fix. Then you pick exactly that cross join to fix. You're not gonna fix all of the cross joins. It's not needed. We only need to fix cross joins that are being touched when you create a group.
I have a question. So I think you have already answered it, so I'm just summarizing it. So identification is across the app, because pipeline will fail because it's a whole test suite. It is going to fail even in other areas, not just while creating a group. So identification is across the app, but fixing is only for that page where you create a group. Is that what you're trying to say?
Yes, exactly. So like we're gonna allow a bunch of those. We don't know that they are failing, but we're gonna only fix like a single ones.
Okay.
So like they're gonna be like, I think up to maybe 5 that we're gonna fix cross joins on that part of the effort. So really like the bulk of the work is really identify and classify pretty much.
Yeah, identifying and allowing. I think if you're only fixing 5, I think the failures will be more than maybe like 50 or a number greater than that. So allowing all those might, but it's a repeatable process.
And basically, this is my talk. You ask about the pure MR. This is like the biggest MR that I've been working on, that I try to look at to get like the as green pipeline as I could. And this probably catches most of those cross joins, or almost all of them. Basically, we would pretty much, in most of these cases, add something like that, depending on the approach that you take. You maybe add .allow cross joins across databases with some referencing URL to just simply catch it. That we would pretty much put in the backlog. And out of this list of the issues, you would simply pick just the ones that are being shown in a log. It's going to be visible in a log that this is the cross join that was allowed, because there is like a specific Magnolia comment annotation added to the SQL query when you call this method. So if you would use this method and you then go to the SQL log, or like log/development log, you're gonna see all of the queries that were annotated pretty much with the cross join. So if you find this kind of query that is annotated, this is pretty much as part of that workflow. This is really like your target to fixing only out of the list of the issues that were identified. And it's really like rinse and repeat process. It's slightly boring, to be honest, but like we have to go through this initial classification of setting the cluster-wide and cell database, because then it's gonna be way easier the more tables you add. The more tables you add is basically the amount of the values generated gonna be going down step by step, because most of these things gonna be identified already. So that's the idea how I was kind of envisioning how we would use a demo. But it's pretty much just specific opinionated workflow. No, any other page has to work, only that page and that workflow. Rinse and repeat on tables pretty much. Only on the tables that you observe as part of this workflow. Classify only the ones that are needed. You probably don't need to classify all of them. So I guess it's more like figuring out, do I really need to classify the table? If the answer is like yes, in some cases it's like a little exploration, like if it's needed or not. Then I'm just gonna classify and get pipeline green by adding these allow cross joins or adding to spec allow list. Okay, and there are gonna be also foreign keys to be fixed, because you're gonna touch tables that gonna use foreign keys. And like, for example, these foreign keys is not gonna work. So as part of the spec failures, it's still also allowed by this query, but if you remove that, there are gonna be foreign keys violations. So some of the existing foreign keys crossing boundaries will have to be migrated into loose foreign keys, but it's pretty mechanical step with already existing script that you could use for that purpose. So this is what I did in my POC-MR. I just ran a script to generate a loose foreign key for every table that was crossing boundaries. There is one more thing that you may be interested why I didn't mention. I didn't mention cross transactions, and I did it on the purpose. Cross transactions are significantly harder to solve but we don't need to solve cross transactions for the demo. Cross transactions being identified and solved is really like a requirement for deploying it into production. But we really don't need to do it now. We only need to focus on the cross joins. We can focus on the cross transactions later. The problem with the lack of the cross transaction being solved now or identified is, which is really not like a problem for a demo. If you do cross transaction, you're gonna open database transaction across two different connections, basically nested, and you're gonna use connection that some connections, like from the outside of the from the outer transaction, may be idling for a very long time, and you can kind of exhaust connection pool, which is like one downside. Second downside, cross transactions are not rollback ready, because you cannot easily generate an event and get like this kind of rollback be done. So in our production code base, we forbid overlaying, having like outer and inner transaction that are targeting different databases because of the performance reasons and rollback reasons. But for the purpose of demo, we don't really care about them, because we only cover happy stuff. We're gonna have to fix them later, but it's more important to fix cross joins now than to fix cross transactions, because we can work even if there are like a cross transactions in the development, but this will not work if there are cross joins, because these cross joins gonna be invalid. So cross transaction is something to keep in mind. This is like the problem, but we don't specifically have to solve that now. We can kind of maybe work and identify that concurrently if you have actually capacity to do it. But it's not really like a requirement to do demo, because demo doesn't depend on the need to solve cross transactions. This is one change to the prior plan, because previously it was like I identify and fix all of the cross joins, cross transactions, cross foreign keys. Now it's basically fix, identify and fix only specific cross joins and fix cross foreign keys as the requirements. Cross transactions I removed from that list as not required. And I think I posted everything that is in the epic because of the issues, because other issues gonna be basically created while you identify cross joins, but you're only gonna pick some of those. So all of the issues that you're gonna create probably gonna end up in the backlog as part of the iteration 2. They're gonna be probably moved later, but some of them gonna get a milestone assigned. Okay, questions.
The cross joins, I guess, we have to be careful not to fix too much, I guess, because especially if we are not sure if something's cluster wide or not.
Yes, and this is pretty easy to identify. I mentioned about this annotation. If you use allow cross join, so any SQL query that is cross join and that is marked through that method allow cross join gonna have a marginalia comment with allow cross joins across databases. So if you run a workflow and you marked all of the cross joins as through that, in the log/development log, you're gonna see a comment with that added. So today it's like just this allow treat key, but You could also just change that to be like including URL if you want to. It's also gonna work. So then you're gonna have like in a comment, sorry, in the log, when you execute the specific workflow, a list of the SQL queries executed with the command with a URL of the cross join. And basically this is the only target that we have to, fix. These
Right.
ones that are annotated there.
So can I ask a different question here? Because so this annotation comes in only if you use the method. But then if there is a way to annotate all such cross DB automatically, and if you run the workflow of creating a group, it will highlight the things that we actually have to fix, and then we can just fix those, right? Have we thought of that approach? But then it will not fail the pipeline or give us the confidence that it is doing the whole thing. But then still for the happy path, might be a viable approach.
Can you say again? Sorry.
So the annotation comes in only when you use this method. But then is there a way we can annotate cross DB transactions automatically so that the logs would show, hey, this is cross joined when we run the workflow of creating a group, and then we can just fix that? I don't know if the question is clear, but yeah.
No, I think like this is also like the way. I think in my head was that I wanted to, but like I think like this was in my head, in my way of working. I will probably go with the cross joins across databases, but Mano, you're gonna try and figure out your own way to do it.
Okay.
So
yeah.
I think if it makes it easier for you, this is given like some trade-offs associated, because from what I hear, like, yes, like we already have this information by query analyzer as part of the comment. There's a query analyzer that, or maybe there is no query analyzer for that. No, there's no query analyzer, because like you could probably have like a query analyzer here, like this one, log SQL query that is having many GitLab schemas, in particular having GitLab main cluster-wide and GitLab main cell as part of that specification, and basically log that very verbosely where it's happening, and from that, and basically try to find those and fix those. So I kind of understand that this is what you're kind of proposing. Like, is there is like another way to identify that is not using this method? Yes, it's like a possible way to do it. But I wanted like to get one thing. Also, I wanted to get rid of that line. GitLab schemas. So, wait a minute. My thinking was I wanted to get rid of that specification, because it like you can do it that way,
yeah.
But and everything gonna be green, and you're gonna fix a very specific ones, and we're gonna get a demo. We're gonna probably get demo maybe faster, because you're not gonna mark everything that is violating, but it's not gonna let's say mark all underlying queries that are cross-joining users and namespaces. So we still have this problem that users and namespaces are gonna generate a lot of failures once we remove that, and we're gonna have to remove that
yes.
pretty soon.
Yeah.
So
yes.
like I think your approach is valid, and it can be like a good first approximation, but I think what I would like to achieve also is like to get rid of that line.
Yes. Yeah, I completely understand.
That's my goal.
Yeah.
But then,
so,
but then we have to put this line back again when we do other things.
Yes, and I was thinking that like regardless of how many failures you observe, you may be kind of putting back and forth to ease work, or just if there is like not a lot of failures, you just kind of try to not put it back. So, but I think like one thing that I felt was overwhelming is like when you put half of the tables in the, sorry, like if you put 50 tables in the cluster wide and the rest in the cell, it's basically gonna have the whole test suite failing. It's gonna basically too many failures to even comprehend how to fix them. So I was kind of like thinking that like doing that iteratively, starting let's say with just 2 tables, you're just gonna still have like a bunch of the specs failing, but from the my POC, it turned out that there's like maybe 40 cross joins that needs to be allowed through that query, basically. So it's still like not a big number to kind of iteratively go through a test suite to remove that. But it was generating like a dozen of thousands of failures because these cross joins between users and namespaces, they are at the root of the project. They are used everywhere. They are used everywhere simply. So this would be my approach, but you're gonna figure out your approach. This is my recommendation, but you're gonna figure out your best way to do it. So I think it's like a valid solution also.
Yeah, I wanted to close the loop around my thought. So I understand. So what I propose can implicitly solve the problem for the happy path, but then it will not push us in the direction we want to go because only your solution will push us in that direction. Because like, this is exactly what Dylan asked us or asked you. Like we are not moving in the direction we want to be when you introduce this YML and allowed cross joins. So at some point we have to remove it, and your approach is perfect to do that.
It's like, so it's not a wrong idea. Like my idea is also not a good. It just has, let's say, it put accent on a different things. So I think like in the initial phase, it's gonna be tricky to figure out which one of those is better. So just do whatever makes you like the most efficient. I personally played with different ideas to find like my way of working around that problem because it's like pretty daunting and pretty weak. But I found like a comfort in just adding this query and like removing that and like pushing that back because I built like a script for like fetching all of the data. So I have this, let's say, MR. I have this bash script that I simply use a terminal for everything. I have like MR, and I don't even look at the GitLab to see all of the failing things. I just run a script and it's gonna pull find a merge request ID, find the pipeline ID, get like all of my jobs, and give me a list of the specs failing. And this is what I was using in my iteration. I didn't even use like GitLab UI to iterate, but if I would have to use a GitLab UI today to go through that method of just removing that and finding all of the fails, oh gosh, it would be pretty harsh. So I kind of adopted my workflow, how to solve that, to make it more efficient, because basically how I was working on my POC also was like, okay, my first iteration, I'm gonna remove the client, I'm gonna push. In the 2 hours time, I'm gonna get back and run my script and see what is failing. Then I'm gonna run a terminal, I'm gonna get 3 from different specs, run them in the terminal, see what is failing, mark these things that are failing as allow cross join, commit, push back, push to GitLab, and get back in the 2 hours to get like a test results. And like when I was doing this iteratively, iteration over iteration, by kind of following this steady process, the list of these things that I had to cover was like simply shrinking significantly because I was thinking more and more things over that. But I was only able to do it because I had the tooling built for that. So I had very easy way to aggregate all the failing specs to get them in the basically, I don't know, 15 seconds instead of going to UI, clicking the pipeline link, clicking a trace, and then scrolling down to get like what is failing. So I work my process basically to make it efficient, to work that way. But if you don't make your, let's say, iteration efficient, it's gonna be pretty bad, and you're gonna try to look for another solution that is gonna make you efficient. So I kind of get where it is coming from. So this was my process. If you are curious, this is all this. I push the script. I just started using script extensively because I just push the script in my bin folder, and on every MR that I have failing, I simply write that, and it's gonna pull me a status of the pipeline and of the failures. So I don't even use GitLab UI anymore for that stuff. That's like how I change my process. I don't use GitLab UI because it's pretty slow to access that stuff. But this is my process. Omar, any questions from you?
No, it's pretty clear.
What I can say, good luck.
Just one final question. Even in the workflow, so we talked about how identification is app-wide, but even in the workflow, we are just going to blindly allow, right? Like it is identifying and allowing across the app.
Yes. Yes. It's like you're not gonna.
We are not solving. Yeah.
We are not solving that. We are identifying them.
Yes.
It's also that we're gonna solve only what we need. And for the things that we don't need, we're gonna ask others to fix that.
Okay.
So like we're gonna go through the plan of just, this is the workflow that we are focusing. We are fixing only what is essential for that. Unless it is strictly required by the changes that we do or the capacity, we're gonna solve some of those things. But for the other stuff, we're gonna simply, similar to the composition, it's gonna be others. They're gonna be, we're just gonna describe what is the problem, give them tools, but they're gonna fix them. We're not gonna be able to solve some of those because they are wide cross joins. They have some very high cardinality. So some of these cross joins is gonna have to be reworked. Some is gonna have to be pre-compute. So we're not gonna be able to efficiently solve all of them. So, and it's also like too big of the task because I think essential for us is like and this is also the question, I guess, that you should think initially. In what cases you make a decision to make something cluster-wide when you classify these tables? Why you do it, for what reason, and what is the data access pattern that forces that? Because ideally the amount of the cluster-wide stuff should be just a handful, just the most minimal thing that we need. Because the cost of saying things cluster-wide is like the amplification of the whole system, on the whole system. So our default decision is like everything is cell, unless we have very strong justification for being cluster-wide, but we need to figure out yet what is this justification. And in my head, iteration 2 was like a way for us to focus on the specific problem of the specific workflow. They're gonna give us some perspective how hard it is to fix those things for the specific workflow, how we go around making decisions what table is where, and how we solve that, because the next step gonna be we're gonna probably go to another team. Hey, this is tables are identified as owned by you. Where you want them to be stored. These are like our classification rules. why you want them to be like a cluster-wide. So we have almost 700 tables. We're not gonna be able to classify all of them and fix all cross joins by ourselves. So I think our role here is like set classification, which is basically user and namespace, which is like the root of the hierarchy. But really make other teams to, let's say, do this fine-grained classification of their adjacent tables below. So, but I think our purpose is like to get a sense of the workflow, get a sense of the classification, build tooling, build like a procedures, figure out like how we're gonna document that, figure out what is essential in our plan, so we could actually work with others with us. So I think this is more like get a practical on the problem right now, so we could kind of work with others next.
And when we create a mask for this, is it okay if we like take a phased approach? Like I remove cluster wide from the YML, then I identify say 10 cross joins and allow it, and then I add it back, and then the pipeline will be green, and then we can push it, right? So we can do multiple masks of the same kind, right?
What do you mean you add back?
So you add it back in the YML, so identify 10 failing things, I allow it, and then when you add it back, the pipeline will be green again, but then you have identified 10 of it, so that can be merged as a one MR, right? So you can take this repeat approach.
Whatever it works for you, really.
Okay.
Like I don't have like a strong opinion. Like it's pretty, let's say, hard thing, or like the hard process is like very repetitive, and like our pipelines are flaky. So whatever makes you like the most efficient to get these things. It could be like, it could also be differently. Like in other cases, I kind of did like a constant rebasing. I had like the MR open, big MR that was like getting all of these things. But I was chipping away from the MR, smaller things that I know that they actually like a problem, and merging the smaller things in the separate and rebasing this bigger MR. I also have a script for basically maintaining a merge train of whatever a number of MRs I have in the chain. So this was my approach. Like I had draft MR open where I was like having all of the changes, but once I get like some critical mass, I started chipping away less controversial changes from that MR until this MR basically become 0.
Okay.
That I would close it. But yeah, to doing that, because I'm kind of used to like a workflow where I have 4 MRs that are in a chain pretty much, and I kind of like have a big at the end, and kind of I slowly chip away from that big to put that in the front of the queue for things to be merged, and then I constantly rebase that stuff. Yeah, but this works for me because I also have a script that can maintain whatever number of MRs I have and keep them in sync and constantly rebase. So I use like, I heavy use rebase workflow. I don't use merge workflow, I use rebase workflow for that stuff. So then always I have, let's say, a clean set of the commits on top of the prior work, because it would not be possible in the merge workflow to have a clean set of the commits.
I am thinking if we want to divide this work between engineers, I think taking a per table approach would be nice. Like add a table to main or cluster wide, remove it from YML, see what's failing, fix it, add it back to the YML, and then merge the MR. So you can do it on a per table basis also.
Whatever works, really.
Yeah.
Like you're gonna figure out your best way of working once you start trying that. Yeah. It's also, I think the tricky part is like how to get it in the parallel. But I was kind of thinking that it could be, maybe there's some sequence only on the identify cross joins between users and namespaces, initially, but maybe not. There is definitely like a separate amount of the foreign keys that are already existing stuff. There is like, if you start identifying cross joins, then you kind of see like these cross joins be identified, and part of the workflow that we need to cover in a demo, it could be like a cross join that could be actually worked on by someone else already. So you have like identify cross joins between users and namespaces, but you also have figure out this classification of adjacent tables. Like you could maybe start going one by one on them and trying to understand like the data relation between those tables where they should live. And maybe in some cases it's even easier. Like maybe licenses or plans is like this easy win to even like put them in the cluster wide already, because why not, if we know that we're gonna have to fix them later. But this easy win, because like I think there are like a few stages in this process. Like it helps to start with something small to get a sense like of the practice. So doing this easy win, if you didn't work on that before, of like just, okay, I'm just gonna change classification of the plants, and I'm gonna rebase this base model and get this MR green to see exactly what is needed to get it green, basically. To just get a general sense of how to approach that before you get more efficient over time on something bigger. So I think it's like a balance on between getting small things maybe done, ramping up to these much harder things. But then if these harder things arrive, like we also have like there may be gonna be like a bunch of the issues that we could actually start working on as part of that.
Okay.
But it's kind of like iterative process, rise and repeat pretty much.
Yes, definitely.
Okay, I'm gonna stop recording, I guess.